Welcome back to Dr. Liu's VCE Chemistry channel. Today, we'll be breaking down the organic chemistry questions from the 2024 VCE Chemistry exam. My explanations might need refinement, so I welcome corrections or feedback from teachers, parents, or students. Carboxylic acids have a unique ability to form stable pairs called dimers, held together by strong intermolecular forces, specifically hydrogen bonds. These forces are considerably stronger than those found between molecules of alcohols, esters, or N-methyl compounds. Consequently, when comparing molecules of similar size, carboxylic acids require more energy to separate, resulting in the highest boiling points among these groups. Isomers share the same molecular formula, but have different structural arrangements. Benzene and the linear molecule 1,5-hexadiene are isomers. Cyclohexane and linear hexene are also isomers. The resonance in benzene leads to stronger average carbon-carbon bond strengths compared to cyclohexane. Cyclohexane and benzene belong to different homologous series because they have different functional groups, cycloalkane versus aromatic. Carbon atoms in cyclohexane and benzene have the same valence electrons, as this is an inherent atomic property. Please draw the isomers of C5H10 that meet the following criteria. They must be aldehydes. They must be structural isomers, different connectivity. Do not include enantiomers. There should be a total of 4 aldehyde isomers. 2 of these 4 isomers must contain a single methyl side chain. The aldehyde group must be on the first carbon atom. We are tasked with identifying 3-chlorobutylbutanoate from a set of ester molecules. The naming of esters follows a specific principle. The alkyl group from the alcohol is named first by changing ol to YL, and the alkanote from the carboxylic acid is named second by changing IC acid to 8. Let's use this principle to name the following esters. Structure A is propyl 3-chloropentanoate, structure B is 3-chloropropylpentanoate, structure C is butyl 3-chlorobutanoate, and structure D is 3-chlorobutylbutanoate. The melting point can indicate a solid's main component, 1 mark, and the purity, 1 mark. A sharp melting point matching a known value suggests the identity of the major component, and a broad or lower melting point range signals the presence of impurities. For a carbon atom to be a chiral center, it must be bonded to 4 different substituent groups. Linalool contains only 1 carbon atom that meets this criterion. Hexane does not react with iodine as it contains no carbon-carbon double bonds, unlike linalool, which does. Each linalool molecule contains 2 such bonds, meaning 1 mole of linalool reacts with 2 moles of iodine. Since 0.042 moles of iodine reacted completely, there must have been 0.042 moles, 2 is equal to 0.021 moles of linalool in the mixture. This amount of linalool weighs 3.234 g moles times molar mass, and makes up 22% of the total sample mass. To obtain purified linalool from crushed lavender, the mixture should first be filtered. Linalool can then be extracted using a nonpolar solvent, as linalool is an oil and is soluble in such solvents. Furthermore, the solution containing linalool should be further purified by fractional distillation or chromatographic columns. Recrystallization is not a suitable purification method because linalool is an oil and cannot form crystals. The reaction pathway begins with compound E, a hydrocarbon, and finishes at compound N. Compound E reacts with chlorine to form 1-chloropentane. This happens because it's a substitution reaction where a hydrogen atom on E is swapped for a chlorine atom. This means compound E is pentane, C5H12. When one chloropentane reacts with NaOH, the chlorine is replaced by a hydroxide group, forming pentane 1-ol, compound L. The semistructural formula for compound L is asked. Propene, C3H6, reacts with water to make propane 1-ol. The UPAC name for compound M is asked. Pentanoic acid reacts with compound M to form compound N. The main functional group in pentanoic acid is the carboxylic group. You can test for this group using IR spectroscopy. It will show two peaks for the OH bond, 2500 to 3500, and the C equals O double bond, 1800. Also, since it's a weak acid, the carboxylic group reacts with metals to produce hydrogen gas, or with carbonates to produce carbon dioxide gas. You will see bubbles formed by both gases. Pentanoic acid and propane 1-ol condense to form compound N. Compound N is an ester called propylpentanoate. This name tells us it's made from propane 1-ol, giving the propyl part, and pentanoic acid. Paracetamol is synthesized using two reactions. In reaction P1, liquid ethanoic anhydride and solid 4-aminophenol react to form paracetamol, an ethanoic acid. Alternatively, reaction P2 involves the reaction of liquid ethanoic acid with 4-aminophenol to produce paracetamol and water. The efficiency of a chemical reaction is quantified by its percentage yield. This metric represents the ratio of the actual product mass obtained from a reaction to the theoretical mass that could be produced, as determined by the stoichiometry of the reactants. To calculate the percentage yield of paracetamol in reaction P2, one must first determine the theoretical yield of paracetamol, followed by calculating the actual mass, as a percentage of this theoretical mass. The percentage atom economy shows how well a chemical reaction uses its atoms. You calculate it by comparing the molecular mass of the product you want to the total molecular mass of everything you start with. To find this percentage, first add up the molecular masses of all reactants, like 4-aminophenol and ethanoic acid. Then, divide the molecular mass of paracetamol by the total and multiply by 100 to get the percentage. Reaction P2's percentage yield is lower than P1's, 41% versus 87%, but it boasts a higher percentage atom economy, 89% versus 72%. At its core, green chemistry aims to design products and processes that minimize both the use and generation of hazardous substances, ultimately promoting sustainability. A relevant green chemistry principle, atom economy, is higher for reaction P2 than for reaction P1. However, both reactions produce waste. P1 yields ethanoic acid, while P2 results in wastewater. In line with the green chemistry principle of waste prevention, it's important to consider the type of waste produced. Reaction P1 yields ethanoic acid, which is more toxic and demands different treatment than the wastewater from reaction P2, even though P1 has a significantly higher yield and could produce less waste by volume. The section on organic compounds is worth a total of 29 marks. This includes 4 multiple-choice questions worth 4 marks and 2 short-answer questions worth 25 marks. This 29-mark section represents 24.2% of the total possible score of 120 points. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.